directly. A revenue flight is planned for the transport aircraft. The takeoff mass is not airfield limited, meaning this particular aircraft doesn't have a performance limited takeoff mass. Dry operating mass, performance limited landing mass, fuel on board at RAM, taxi fuel, trip fuel, contingency reserve, alternate fuel, passengers on board, standard mass for each passenger, baggage per passenger, traffic load maximum. Determine the maximum cargo load that may be carried without exceeding the limiting airplane landing mass. Okay, so we have DOM, we have performance limited landing mass. Okay, so this is fuel on board is given and contingency alternate fuel. So first let's find out regulated takeoff mass. Now since we want to find out regulated takeoff mass, it will be equal to landing mass, performance limited landing mass plus trip fuel plus the trip fuel, right? So what is performance limited landing mass? It is 55,000. Fuel is 99,730. 55,000 plus 9,730 is 64,730. Okay, so regulated takeoff mass is 64,730 kilograms. We have to find out cargo. We know the payload. Payload is nothing but passengers and their baggage. Now we have 130 passengers on board. Payload equals to passengers and their baggage, right? So how many passengers? 130. Every passenger weighs 84 kg. So one passenger is 84 kg. 130 will weigh 130 into 84, 1,920 kg. Next, standard mass. Baggage per passenger 14 kg. So one baggage is 14 kg. So the total baggage weight will be equal to 130 into 14 is 1820 kg. Okay, 1820 kg. Now we have to find out the maximum traffic load that can be carried. Regulated takeoff mass is equal to dry operating mass plus fuel on board or takeoff fuel plus payload or traffic load, right? So let's write it. Let's write traffic load. Now payload means passengers and the baggage. Traffic load means passengers, baggage, cargo, non-revenue generating load, etc. So most of the times they are used interchangeably, but when we are dealing with questions like this, which are specific, we will use the specific term, traffic load. So traffic load will be equal to regulated takeoff mass minus DOM minus DOM plus fuel on board. So regulated takeoff mass is what? It is 64,730. DOM is 34,930. Fuel on board or takeoff fuel is trip fuel plus contingency reserve fuel plus alternate fuel. So everything except taxi fuel. So 9,730 plus 1,200 plus 1,600 is 12,530. 12,530. So 64,730 minus 12,530 plus 34,930. 47,460. Okay. So minus 64,730. 17,270 kg. So that is the traffic load that you can carry. Now what is the payload that you are carrying? 10,920 passenger weight, 1,820 baggage weight. So existing, I'm writing here, existing payload equals to passenger weight, total passenger weight 10,920 plus baggage 1,820. 12740. Okay, that means we have how much space is remaining? 17,000 traffic load minus payload. 17,270 minus 12740 is 4,530. That means there is extra space of 4,530 uh, remaining, and we can use this extra space of 4,530 to load cargo in this aircraft. This cargo will generate revenue for the company, cargo, parcels, post, etc. So correct answer is option alpha. In the remaining space, we can put or we can load cargo. Okay, so next 35. The empty mass of an aircraft is 44,800. Operational items including crew are 2,300. Operational items means variable load. If the maximum zero fuel mass is 65,500, what is the traffic load which can be carried? So zero fuel mass minus dry operating mass equals to traffic load. Now what is the dry operating mass in this question? It is basic empty mass plus operational items plus operational items. So basic empty mass is 44,800. Operational items 2,300. So 44,800 plus 2,300. 47,100. Zero fuel mass 65,500 minus 47,100 equal to 18,400. So this is your traffic load or payload. Option Charlie. Next, DOM performance limited takeoff mass, landing mass, zero fuel mass given. Fuel requirements, fifth fuel, reserve fuel, alternate fuel given. What is the traffic load that can be carried? Again, so make three columns, one for takeoff mass, the second for landing mass, and the third for zero fuel mass. In the takeoff mass column, you are going to write the takeoff limitation 127. In the landing mass column, write the landing limitation 985, 98.5 plus fifth fuel 29.3. 98.5 plus 29.3 is 127.8. Zero fuel mass 89.8. Takeoff fuel or fuel on board. Zero fuel mass is zero fuel mass plus fuel on board equals to takeoff mass. So we are going to add fuel on board here. That is fuel on board or takeoff fuel is trip fuel plus reserve contingency plus alternate fuel, right? So 29,300 plus 3,600 plus 2,800. So 35,700. 35.7. 25.5. So regulated takeoff mass will be 125.5. ठीक है? So the lowest of them all. Next, step number 2, payload or traffic load is regulated takeoff mass minus dry operating mass plus fuel on board. So 125.5 minus 35.7 plus DOM 85. 20.7. So that is 4.8. 4,800. So option alpha. 37. An additional baggage container is loaded onto the aft cargo compartment but is not entered in the load and trim shed. The airplane will be heavier than expected and calculated takeoff safety speeds will be what? It won't be achieved or unaffected will give reduced safety margins. So since your aircraft is heavier than expected, the takeoff safety speeds will also get affected. It, the takeoff safety speeds won't be achieved or unaffected will give reduced safety margins. So option Charlie. Okay, since you will be flying under an illusion or you will be flying with incorrect or wrong speeds. Okay, the actual speeds will be much greater or much more than the speeds that you are considering, right? Heavier aircraft, more momentum, more speeds required. So since there is this disparity or difference between the speeds that you are thinking are correct and the actual speeds that you must be flying at, the safety margin, okay, the margin error increases or the safety decreases. So it will give reduced safety margins. Okay, that's why it's very important that you enter all the items in the load and trim sheet. You don't miss out anything and all your calculations are up to the mark, are accurate basically. Next, 38. Fuel loaded onto an airplane is 15,400 but is erroneously entered into the load and trim sheet as 14,500. So the weight that you have entered in the load and trim sheet is lighter one. Okay. This error is not detected, but they will notice. What will they notice? So what will be the effect or consequence of this? So the pilot thinks, the flight crew thinks aircraft is or the fuel is equal to 14,500. But the actual fuel in the fuel tanks is 15,400. That means the actual weight of this aircraft will be 1000, at least 1000 kg heavier than the weight the pilots are imagining, right? Heavier aircraft means uh, heavier aircraft means more demands on aircraft in terms of speed, lift, and runway requirement, runway distance requirement, etc. Right? So the error is not detected by the flight crew, but they will notice some changes in the flight environment or in the cockpit, like speed at unstick will be higher than expected, V1 will be reached sooner than expected, the airplane will rotate much earlier than expected. So since this aircraft is heavier, it won't rotate much earlier than expected. It will take a little bit more time to build that ground speed in order to achieve your rotation speed. V1 will be reached sooner than expected. Speed at unstick will be higher than expected. So V1 will be reached sooner than expected. Wrong. V1 is the takeoff decision speed. Okay, since your aircraft is heavier, the actual weight is heavier than the original or than the one you are imagining. This heavier aircraft will take some time to build momentum and reach your V1 speed or achieve that V1 speed. Okay, so the time taken will be more. That's why V1 will not be reached sooner as per your expectation. Now we are left with option A, speed at unstick will be higher than expected. Okay, next. Question 39. When considering the effects of increased mass on an airplane, which of the following is true? Increased mass. Increased mass on an airplane can be in terms of additional cargo that you have put in the cargo compartment, more passengers, or in flight, the mass of your aircraft can increase apparently by increase in load factor. You are turning your aircraft, etc., or turning your aircraft. Basically, this is when the load factor increases, right? And the mass of aircraft can be assumed to increase. So stalling speeds will be higher. Yes, heavier aircraft, faster stalling speeds. Flight endurance will be increased. No, endurance will decrease. Heavier aircraft means heavier lift requirement. Heavier lift requirements means the angle of attack of that aircraft must be increased. Increase in angle of attack. Okay, when you increase the angle of attack, the speed of aircraft will automatically decrease. If you want to stop that from happening, you will have to add power. When you add power, you consume fuel, and when you consume fuel, the endurance automatically decreases by that much. What is endurance? But nothing. Endurance is nothing but the duration or how long the fuel in your fuel tanks is going to last, right? So endurance will decrease, not increase. Gradient of climb will be higher. No, gradient of climb means how much height or vertical distance you will achieve with respect to the horizontal distance, horizontal ground distance. So heavier aircrafts will have or will have lower climb gradient. Okay, they will not be able to achieve large vertical distances in short horizontal distance because of their weight. So the correct answer will be stalling speeds will be higher. Always remember, weight increases, stall speed increases. Okay, next.